Finite Mathematics, Chapter 7, Section 1, Graphing Linear Inequalities in Two Variables. Now, this should be a review. The graph of a linear inequality is a graph that consists of all the points in the plane whose coordinates satisfy the inequality. To graph a linear inequality, the first thing we're going to do is treat it as an equation and graph the line. This line becomes a boundary or a border. It divides the plane into two halves. The second thing we're going to do is shade the half plane that contains the coordinates satisfying the inequality. Now, a few rules about that. If the inequality is in the form y is greater than or equal to mx plus b, the solutions are on or above a solid line. You're going to draw it solid because of the equal. If it's y is greater than mx plus b with no equal, then the solutions are above the dashed line. If it's y is less than or equal to mx plus b, the solutions are on or below a solid line. And if it's y is less than mx plus b, the solutions are on or below a dashed line. Okay, here's an example. If we're going to graph the inequality y is greater than or equal to 1.5x minus 3, the first thing we're going to do is, like on the graph on the right, we're going to draw the line y equals 1.5x minus 3. The second thing we're going to do is in the middle, we're going to figure out where are the points that satisfy the equation. We already said that since it's greater than, they're going to be above. You could also test a point that's in that region, like 0, 0, and prove to yourself that indeed those points do make the inequality work. Once we've determined that that side makes the inequality work, then we're going to shade that side. Now you try it. Pause the recording, try the example, resume the recording to check your answer. And there we go. We solved for y, to get y by itself. That way we can use our trick that since it's less than or equal to, the shaded part will be below. The equal to makes it a solid boundary line. Let's try these two inequalities. These are a little different because they're going to be horizontal and vertical lines. Pause the recording, try it out, resume the recording to check your answer. Okay, these are descriptions of the solutions. The next slide will have the solutions themselves. There we go. Y is greater than or equal to 2 is the line y equals 2, and it's shaded above. X is less than or equal to negative 1 is the line x equals negative 1 and is shaded to the left. Try this example. Pause the recording and then resume the recording to check your answer. All right, let's talk about systems of inequalities. A set of at least two inequalities is called a system of inequalities, and the graph of the system consists of the set of all points that satisfy all of the inequalities in the system. The region that contains all the points that satisfy every inequality is called the feasible region or the region of feasible solutions, and you're going to see this term a lot in this chapter, so get that down. The feasible region just means that area where all the points make every inequality work. Now try this example. Remember, what you want to do is graph each inequality, and your solution will be where the shaded areas overlap. So here we have each graphed individually, and then you can see where they overlap gives us our solution. Now try this one. Here you see it in two ways, using technology and then also graphed by hand. And try this example. Again, pause the recording and resume when you're ready to check your answer. Okay, we have a bodybuilder that wishes to supplement his regular meals with protein shakes and bars. The protein shake consists of 30 grams of protein and 325 calories. The protein bar has 25 grams of protein and 275 calories. During a 5-day work week, he wants to achieve at least 350 grams of protein, but fewer or equal to 7,150 calories. So you're going to write a system and then solve. I suggest you make a chart. Let X represent the number of protein shakes he will have, and Y represent the number of protein bars. Pause the recording, give this a try, and resume the recording to check your answer. Okay, here we have the chart. The number of units would be represented by X or Y, the grams of protein, number of calories. Notice across the bottom, for grams of protein, he wants a minimum of 350. So when we write the equation 30x plus 25y, we're going to have greater than or equal to 350. For the number of calories, we want it to be less than or equal to 7,150. So when we go to the next page, you'll see there's a less than or equal to for that one. And there are our answers. So the region that's shaded in would be how many of each he can have. All right, the rest of these are classwork. Give these a try. Pause the recording to do it and resume the recording to check your answer. Do that for the remainder of the video.